Today we're going to be starting our unit on three-dimensional shapes, kind of going away from two-dimensional. We're going to be looking at three-dimensional for today. Some terms that you need to be familiar with are coplanar. Coplanar means that it occurs in more than one plane. And when I'm referring to a plane, I'm talking about a flat surface, like the plane that your desk is on is the top flat surface of your desk. The plane of the wall would be like the flat surface that goes along the wall. So coplanar means along a plane. Or flat surface. And you usually think of a plane that extends on in all directions. Parallel. Parallel means that no sides touch or at all. And they will never intersect. Never cross or intersect. And solids are three-dimensional shapes or figures. And that's going to be what our focus is really for today. Okay, 3D shapes are made up of planes or parts of a plane. Now you can have more than one plane that intersect, and they can intersect along a line, such as the corners of two walls would be two planes that intersect along a line. You can have two planes that intersect at one point. So this one would actually be all three of these planes. The yellow one, the blue one, and the green one all intersect at one point. And you could have what we call parallel planes, or a part where they do not intersect at all. They will never touch or cross. All right, let's familiarize ourselves with some more terms. An edge of a figure is where two planes intersect on a line. This would be considered an edge. This is an edge. Anywhere where two planes intersect along a line. A vertex is where three or more planes intersect at a point. And we often use that term when we're talking about two-dimensional figures as well, such as angles, the vertex of an angle, and this is very similar. A face is a flat two-dimensional surface on a three-dimensional shape. And the diagonal is a line segment whose endpoints are vertices that are neither adjacent nor on the same face. In other words, this vertex and this vertex, they are not on adjacent planes, and they're not actually on the same face as given on the outside faces. Skew lines are non-parallel lines that are in different planes and they never intersect. For instance, a skew line might be the one diagonal going across that you had. That would be considered a skew line. It's a non-parallel line that are in different planes and they never intersect. So what would be a skew line of the front and, let's say, the back? What would be a skew line? Non-parallel. Okay, that are different planes and never intersect. Okay, can you go from one corner to the other? Skew lines, non-parallel lines that are in different planes and never intersect. So in other words, from JK, a skew line to JK would be even a line going this way. Okay, see how they're never going to intersect, and they're not parallel either. It'd be like taking this line up here and that line going in that direction. That's an example of skew line. Okay, what would be an example of a face on this figure? Okay, a face would be quadrilateral D, C, B, A, and you usually put them in order as they're given if you were to be tracing around them. Okay, what about a skew line? Can you give me a pair of skew lines? Like what would be skew to segment HD? What would be skew to HD? I can't say FB because it would be parallel. Okay, a skew line would be possibly GF. Okay, CB. Any others? Okay, I couldn't do DA because it would intersect with HD. Okay, those are some examples of skew lines to HD. All right, now let's talk about what do you call these three-dimensional shapes. Anytime you have bases, two bases that are the same, and surrounded by other figures or two-dimensional shapes, you call that prisms, a prism. A pyramid is where it has only one base, and that usually it comes to a point, and the other sides or faces are made from usually triangles in this case. Okay, let's talk about what's the difference between a net plan and a mat plan. A net plan is how do you draw the picture so that if I folded it up, it would make a three-dimensional shape. Okay, this would be a net plan for a possible rectangular prism. You see how you have your two longer sides, your two short sides, and the top and the bottom. Okay, that's a net plan. And just think of when I fold it up like a net, kind of like capturing you, that would make then a three-dimensional shape. Versus a mat plan is telling me how are my boxes stacked to make my figure. So if I have this picture, my mat plan going from left to right would be a 1, 2, 1. So this would be the mat plan of this 3D picture. Let's practice drawing some 3D pictures. Now when you do your isometric dot paper, make sure that your rhombuses or your diamonds are kind of flattened out. That's the best way to start. And I always start with one diamond. Okay, and that's going to be your top. Okay, from this we're going to work our way down, kind of like making the legs on a table. And I only see 3 of them, although we know there's a 4th one. Okay, then I'm going to close it off. Okay, I'm going to go down another one. Close it off. Okay, now I'm going to branch out a little bit. Okay, now what I'm going to do is I'm going to figure out what is my mat plan for this figure. What is my mat plan? Well, starting from, I'm going to have how many little boxes? Looks like there's going to be 5. Okay, in the first box, how many will I have? Starting from the left, go 2, 2, 4, 2, 2. And sometimes we could even add some back behind there. I might even have another one, and then you would have another 2 back there as well. Okay, but you have to be careful for the hidden ones. So this is what a mat plan is. A mat plan is stating how many boxes stacked high to make the shape that I have on isometric dot paper. All right, let's kind of take a look at these two shapes. What am I going to call this figure? Looks like it's going to be a prism because it doesn't come to a point. But what kind of a prism? We need a more specific name. Usually a prism is named by its base, and this one's actually tipped over on its side. Okay, what are the bases? Remember, the bases are exactly the same. They're triangles. So we call this a triangular prism. A triangular prism. Okay, let's find the base here. This is your base. What is the shape? Looks like it's a pentagon. A pentagonal. And because it comes to a point, we will call it a pyramid. Okay, so any prism has 2 bases that are exactly the same shape, and pentagonal pyramids all come to a point, or pyramids come to a point. All right, let's try these. I want you to name what B, C, and D are. When you're finished, I want you to check with your partner. All right, what'd you get for B? Okay, the bases seem to be rectangles, so it's a rectangular prism. And sometimes you may see it called just a solid, a rectangular solid, but a rectangular prism. Okay, what about C? Very good, a triangular, because the base is a triangle, triangular pyramid. And the last one, what about that one? The base is a hexagon, or the bases are hexagons, so it's a hexagonal prism. All right, let's try just a few more. We're going to use this figure at the right to identify the following points, lines, or planes. Let's identify parallel planes. Okay, one of them would be plane BCDA and plane FGHE. Okay, that's number one. Okay, give me an example of skew lines. Let's say what would be skew to BC, segment BC. Okay, would be skew, FE would be skew. Any others? Or GH, very good. Okay, number three, 2 points that form a diagonal when connected. Okay, you could do F and D, or B and H, or G and A, or C and E. Very good. And the last one, intersecting planes. I could say plane BCDA and which one intersects BCDA? Well, you could have a variety. Let's go with plane ADEH. So where do they intersect? Along line AD. Very good. Any questions? Okay, now let's name each solid, and then we're going to identify how many faces and edges and vertices it has. Okay, this is a rectangular prism. Okay, how many faces? Looks like 6. How many edges? Looks like 12 edges. And how many vertices? Looks like 8. Okay, let's try this one. What's this one called? Okay, it's a triangular prism. And number of faces. 5. Edges. 9. Get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks right. And vertices. 6. Good. Okay, and the last one. Okay, we're going to say a rectangular pyramid because the base is a rectangle. And the number of faces. 5. Edges. 8. And vertices. 5. 1, 2, 3, 4, 5. Looks good. Any questions on this? Okay, this concludes our lesson on our introduction to 3D shapes. Tomorrow we'll be looking at surface area and volume of these shapes.